Hello, I'm Wellington with PX5, and today we'll be talking about the functional safety certification from a development and runtime perspective using the comprehensive solutions from PX5 and IAR. Functional safety certification is an important element in ensuring the safety of devices for safety-critical applications. So, if you're working with automotive, medical, rail, and industrial, this is a non-negotiable. But it might be a great investment. The certification means that you get improved quality, enhanced reliability, improved time to market, fewer defects and recalls, and reduced product liability. All of these leads to enhanced customer satisfaction. And the best of all, even non-safety critical devices realize these benefits. So you get these benefits even if you don't need the certification. Let's take a look at the IEC 61508-1, which is the foundational international standard for functional safety of electric, electronic, and programmable electronic systems. It is widely used in industries such as industrial automation, energy, transportation, medical devices, and process control. You'll find many sector-specific safety standards, such as the IEC 61508 for industrial, the ISO 26262 for automotive, the IEC 62304 for medical, and finally the EN 5128 for rail. And it's important to notice that this is a widely recognized and accepted standard used throughout the world. So let's talk about Safety Integrity Level, or SILs. Within the IEC 61508, there are Safety Integrity Level, commonly referred as SILs. Now, each SIL has a numeric value, ranging from 1 to 4. 1 being the lowest and the 4 being the highest within the 61508. The SIL level required depends on the use case. If the device failures could contribute to injury or equipment damage, but the damage is not catastrophic, SIL 1 might be applicable. Another example is an overflow sensor, which could be SIL 1 if this overflow only causes cleanup and downtime expenses. On the other side of the scale is SIL 4. This level is reserved for safety-critical devices where a malfunction can result in catastrophic events. Of course, the amount of rigor associated with SIL 4 certification is much greater than what's required for SIL 1. For example, SIL 4 certification requires 100% statement and branch decision coverage testing, while SIL 1 does not have this requirement. As I mentioned before, there are several important sector-specific safety standards that are derived from the 61508, as shown here. So automotive, medical, rail, each one has its own safety integrity level. So the ASIL D is the highest for automotive, Class C the highest for medical, and SIL 4 the highest for rail. Let's take a look at the functional safety certification process. So the functional safety certification is a set of guidelines or rules that must be followed for safety-critical device to be certified. Then you apply those guidelines to your product and process to ensure that you're following them. Then you get a certifying entity, so those folks can independently verify everything is in order. Usually, there will be a cycle of findings and fixes before you get to the end of this process. So there might be some back and forth. And then finally, your device gets certified. Now, one of the fastest ways to achieve the high standards required by these industries is to leverage pre-certified parts and components. In this case here, By leveraging certified development tools and runtime software, in this case an RTOS, you would only have to worry about getting your specific device firmware certified. And this would streamline the process to get your product completed. The functional safety of a typical safety-critical device can be viewed from two different perspectives: the build time and the runtime. Let's start with build time, which is the phase during which all device firmware that's typically written in C and assembly is compiled, assembled, and linked into one image that will be flashed to the device. Once loaded, the device powers up, and then the device executes the firmware image. The execution is what is called the runtime. If you're using pre-certified development tools and pre-certified runtime components, you will greatly simplify the certification process. Because instead of having to address these in the device firmware certification, developers can simply reference the pre-certification and concentrate only on their device firmware. If you're looking to simplify the certification process for your product, we might have a great solution for you. PX5 and IAR offer a comprehensive solution that encompasses both build time and runtime requirements of safety-critical devices. As you can see here, during build time, we have IAR certified compiler. And in this scenario, for the runtime, we have PX5 RTOS, the network stack with the TCP/IP, and the file system. This combination is unique in the embedded industry and offers great value to developers making safety-critical devices, reducing development and certification time while making superior products. Now, looking specifically at the runtime side, PX5 RTOS can be used in applications requiring the highest IEC 61508 certification classes, which means devices requiring SIL4, ASIL-D, Class C, and SIL4 can instantly leverage PX5 RTOS and middleware in their designs. Not only do we recommend using the pre-certified IAR development tools to our customers, but we also leverage them ourselves. For all of our development and certification, we know firsthand how valuable IAR tools are. Using IAR tools, we demonstrated 100% statement and branch decision coverage testing. We also leverage the CSTAT for the static analysis requirements of SIL4 and ASIL-D. There are also some additional webinars if you're looking to get more into how IAR can help you. There's one that's called Hints for Safe C and C++ by Nicholas and Raphael. And there's another one for Safety Guide, Validating Your Application with IAR Tools by Sean Prestridge. I'm going to leave links for both in the description. It's also important to mention that the functional safety certification for PX5 RTOS, PX5net, and PX5 file is portable, so it is not tied to any particular processor. Now, to achieve this level of portability, there is one small binding file that must be included in the device firmware certification. This file binds the PX5 RTOS generic C code to the underlying processor. It is quite small. It contains approximately 11 assembly functions. And of course, we provide all of the documentation and test cases for the inclusion of this file. PX5 provides all the necessary artifacts for your certification process. So for each component, this will include the TÜV certificate, the safety manual, technical report, and certification report. Using all of these artifacts, developers can solely concentrate on their device firmware. So I'll stop my presentation here, leaving you with my contact information, our website where you can go to learn more, get samples, white papers, and know how to get started with PX5 RTOS. Thank you.